Hello, today I'm going to be making a small little application which finds the nth prime number or other prime numbers, and I'm just going to try something because I found a method online which seems pretty easy on finding prime numbers. It was from a video by Numberphile. I'll put the link to the video in the description. I'll be programming it in idle in Python. I'm going to make a new file. And yeah, it uses a infinite series called the Lucas set, similar to the Fibonacci, but it starts off with numbers 1 and 3. So let me just program this. So I'm going to start off by I'm going to define a Lucas function. Better put that there. The first numbers in the series are going to be 1 and 3. Then I'm going to do for I in range, I'm going to do 0 and x minus 2, because what I want to do is have the user input how long the series is going to be, and since these first two are already defined, I'm going to minus 2. So the series will be as long as the user defines. And I'll get to how this works. This will be used to calculate the nth prime number. So I'm going to do lucas.append. This adds something to the end of the list. Lucas len Lucas minus 1. And I'm going to do plus. I'm going to copy this again. Do I have my parentheses right? This. Plus that. Okay, so what this does is it's going to take the last item and the second to last item in the list, add it together, and put it on the end of the list, okay? And I'm going to say output is equal to Lucas, or actually I just do that again. There. So the output is going to be the last thing after it's done adding stuff to it. So this adds everything, and once the list is as long as the user wants it to be, it's going to return the last value in the list, and you'll see why that's useful. I'm just going to make output equal to 0. I'm going to define it first. I'm just going to add this. Okay, so I'm going to define nth as, I don't know, the nth prime number, because you want to find, I don't know, the 5th prime number or the 1st prime number, whatever. So I'm going to do x is equal to 0 and y is equal to 3. So x is going to be the amount of prime numbers we've found, and y is going to count through all the numbers. So I'm going to do while x is not equal to the input, so nth. So the user wants to find the nth input, and while we haven't found that, we're going to keep going. So once we've found the nth prime number, it's going to return that eventually. So I'm going to Lucas y. So it's going to Lucas this to test if it's a prime number. If output minus 1. So I should really explain this. The way that this program tests if it's a prime number, and this is actually a really cool method, is it finds, to test if a number's prime or not, it takes that number, finds that number in the series. For example, the third number in the series would be 4. the fifth would be 4, 7, 11, etc. The fifth would be that. So it takes that number, minuses 1, and sees if it's a factor of that number. And if it is, then it is prime. For example, 5 to 11. 11 minus 1 is 10, and 5 is a factor of 10, meaning 5 is prime. And that is a really simple, non-CPU intensive way of finding the nth prime number, or to see if a number's prime. So I'm going to do modulus y equals 0. So what this does is it's calculating, as I said before, to test if there's any remainders. So if, for example, the 11 and 5 example, if 11 minus 1 is 10, divided by 5 has no remainders, that's what modulus means. 10 divided by 5 has no remainders, then it will do this. So I'm going to do x plus equals 1 and y plus equals 1. I'm going to do else simply y plus equals 1. So y is going through all the numbers while x is counting how many primes were found. So when we come across a prime, I'm going to increase prime by 1, and no matter what we come across, the number's going to increase to test the next number. And then after all of this, I'm going to print y minus 1, and that's going to return the prime number we've found. Oops, sorry. Sorry about that. So I'm going to do number equals int, because I only want people to enter integers into this, because 2.5 can't really be tested if it's prime or not. It's got to be an integer. Input, find the nth prime number, and then I'm going to make another print, and then I'm going to call this function up here, and then number minus 1. So let's save this as, I don't know, Lucas Prime. It doesn't matter what it's called. I'm going to run it. Where did I go wrong? I also noticed that. I'm really bad at remembering my colons. Find the nth prime number. What prime number should I find? What is the 10th prime number? 29. Open up this. First 10 prime numbers. List of the okay. So what is the 10th prime number? 29. There we go. Can I run this program again? I'm just gonna do that's not gonna work. Run. Find the nth prime number. What is the 16th prime number? It's gonna return 53. There we go. Just to test the extreme of this, what is the 150th prime number? As I said, this is a really easy way of doing this. So you can go pretty large with these, and it's not going to harm your computer very much, because this is a really easy method. So yeah, the 150th prime number is, where is it? There we go. So I'm assuming that's 141 plus 9. Anyway. Well, that's finding the nth prime number. I might just... A little bit of a bonus. You can add a try here. And except print that's not a integer. So what this here will do is if the user inputs 2.4 whatever, it'll return that. If they input anything, it can't be tested. Without this, it would return an error because it would expect an integer input. I'm going to make a way to see if you can find a prime number. So I'm going to do define prime, test if a number is prime. So I'm going to do x again. Lucas x that'll return the output value. So if actually I can just reuse this code here. Then print prime. I could do if this is not equal to 0, but it would be easier to just do an else. So I'm just going to comment that up. This explains better, but this is just easier. Because if it's not prime, then it has to be the only other thing is not prime. So print not prime. Let me just add my quotations here. Run this. Oh my gosh, sorry. I keep forgetting to add colons. Find the, so I didn't remove that. And then I'm going to do prime. What number should I find if it's prime? So I know 137 is prime. 137. Why is not? Oops. Okay. You know, I'll just do that. Prime 137. So it should return prime. There we go. It is a prime. As we can check by that. I'll do 132 because I know that's not prime. Prime 132. Not prime. There we go. So this application now says the nth prime number and if a number is prime or not. I'm going to end it here as this is now functional. And yeah, thanks for watching.